Hello, good morning, good afternoon, and good evening. I'm Adam Clare, and thank you for tuning into this episode of the Scintam Engineering podcast. Today I'm joined by James Kell, Robotics Technical Director at Amentum, who is focused on pioneering robotic and remote handling solutions across multiple industries. James, welcome to the podcast.
Thanks for having me.
Brilliant to have you with us, James. And I know that you've been doing a little bit of work with Scintam Engineering, a company I've been involved in since its foundation, and also the University of Manchester. Could you tell us a little bit about how that came about?
Okay, very quickly. Amentum, generally speaking, we're a global engineering technology consultancy. We support government operations really around all sorts of science, sustainability, security types of proper challenges. The team I represent is robotics and remote handling, and we've basically designed, develop, and also deploy customized solutions to basically extend the life of or keep people out of harm's way in different kind of high value critical national infrastructure. And that's classically nuclear industry, sewers, flood defences, road, rail, these kind of things that we take for granted, but if they go wrong, then we know about it. So yes, we've been working with Scintam, but the reason for doing that...
Before you get to that, wasn't it formerly Jacobs?
Correct. Really quickly, the bit that I'm part of was called or known as Critical Mission Solutions within Jacobs. So Jacobs split itself in half, and the CMS business, Critical Mission Solutions, spun off on its own, but it was bought by Amentum, who are themselves a spin-out from AECOM. So it's a fairly new name in the business, but as far as we're concerned, we're still operating with the same customers. It's just a different name above the door.
And it's an engineering-driven business, isn't it? Could you give us a feel for size and shape?
Yeah, so it's there's around sort of 60,000 of us across the business.
So not small
then? No, and there's always someone out there that we can find to help fix the problems.
Which probably leads us on to the next point here. So how did you end up kind of connecting with University of Manchester and then Scintam Engineering?
Yeah, so the University of Manchester, the relationship with us and them goes back a long way. And both of us have a fairly good reputation in developing robotics for nuclear industry. So what we did was we got some funding through the UK government to form a what's known as a prosperity partnership. So that is known as Cradle. So it's essentially an extension almost. We see it as an extension of our team as part of a way of getting into research and academics, and which is really powerful. I love talking to academics in general because it provides a different level of different angle to the conversations. Always helps you think differently. But Cradle itself is like an industry-led research group, and we think there's around 40 of us or so that are some way related to and working in Cradle between Amentum and the University of Manchester. And it's got a very cross-sector focus to it, in that we are looking for any kind of high-value or critical national infrastructure, dangerous, demanding types of environments. And we're looking to develop robotic solutions to help get people out of harm's way in those types of areas.
Awesome. And just I did make a mistake when I was introducing you, James, is that you are PhD, so it is really Dr. James Kell. Do you think that the postgraduate helps you interact with the University of Manchester and understanding academics all the better?
Maybe. Yeah, maybe. I've had a foot in the door, if you like. I decided academia wasn't necessarily for me properly. It was a nice dip. But yeah, I guess it does. It kind of helps, I suppose. Do a bit of understanding how they maybe operate within the structure of the university, perhaps. And I've done a lot of work through previous jobs with other universities, and that's how I came to met you and Scintam actually when I was working with Rolls-Royce, because Rolls-Royce do a lot of their research through the university networks across the world, and the one I was working in is the University of Nottingham.
So that's where that connection was built, obviously.
Yes, so that's where that connection, where I kind of first knew about yourself and the work you do, and Scintam itself too.
Brilliant. So Just developing that then a little bit more, James. So you mentioned, where the business has interests, and one of the things that I'm seeing a lot of now across blue chip engineering companies is capital asset maintenance. So as time goes by, we're leaning more and more on these costly investments to keep things moving, keep things energy stored, keep energy being generated. And I guess that's a key focus for the company that you work for now, in that more and more people are asking questions about keeping capital assets running. Is that right?
Yeah, essentially. I mean, if you look around, certainly the UK, and this happens in lots of the developed world, I suppose, the infrastructure is of usually a certain age.
Mm-hmm.
And lots of it seems to be kind of degrading at fairly similar rates. There's lots of different challenges around that. But the challenges also that we like are the really difficult ones, and that also help with an additional kind of removing people from harm safety factor. So if you're able to, for example, put a drone into a place and get some better data, and you can do it quicker, but you also don't have to put a person at risk by putting them into a confined space, then that's a win in all sorts of ways. So that's the type of thing we're operating in.
So I guess alongside taking away the risk to an operator, you're maybe also trying to simplify some of these things. So if you can take the thinking work, the expertise, they used to call it the artisan skill, out of some of these functions, that's all for the better as well.
Yeah, absolutely. And one of the really interesting bits I think about Cradle is it's not just about robotics for hardware and software, and also infrastructure. The networking capabilities, the architectures, but it's also about human factors and regulatory insurance. So what you talk about there around the artisan bit is really interesting, I think, certainly to a group of people within that research group, because we talk to people from an inspection background, for example, and they say our regs say we need to go and look at that thing and be arm's length away from it. I say, okay, well, that is what you say is written down, but what actually happens? And we start talking about it a bit more. We find out that they not only do they listen and also seemingly smell as well, they touch and they scratch and they tap. So it's like there's loads of other things that aren't necessarily captured in the documentation, but you have to somehow try to capture within a robotic or remote handling solution so that the person can make the same decision as well.
Brilliant. Thanks, James. You mentioned you've been working with Scintam Engineering in the University of Manchester, and that related to kind of a sub-project, I think you'll describe, called RAISE, Robotic Automation of Innovative Spark Erosion. So that was making use of a process that normally sits in a factory, spark erosion or electrical discharge machining, and then trying to deploy that on a robot platform. How did this all come about? Where did the idea come from? How did the people get involved? And what's the end game for a technology like this?
So there's a couple of things, I guess. Firstly, I knew about your group, the Scintam team, from my previous job within Rolls-Royce. So I was aware that this type of technology existed. Otherwise, I don't think I would necessarily. Then the other thing is we've been handed a bunch of decommissioning challenges over the years. And one in particular for a big nuclear organisation requires the dismantling of lots of different tiles. And they're all bolted in. And they're going to be bolted in at quite an aggressive environmental condition and vacuum as well, potentially.
So
there's quite.
I want to go on my holidays then, James.
No, I don't want to go in there either. But so it's the type of place that you don't want to go in, and you're probably going to find bolts that are seized up. So these little kernels of thoughts kind of start to emerge. But then the nice thing about Cradle is it's not just a research project. It's a way of also providing a bit of consultancy in a way to people that we haven't worked with yet, to see if there's any kind of possible future in a collaboration, partnership or similar. And we've been doing all sorts of work with people like National Highways in the UK, for example, people that operate the roads. We gave them a bit of time where they came over and told us their challenges, and we then went down to their place and showed them some quite basic robotic systems to provide them with an idea of how you could do things differently. And all these things just started to kind of get a bit of momentum, and they're now on a point where they're trying to pay us to do some real work between the University of Manchester and Amentum. So it's the kind of a way of kind of starting off conversations and collaborations. So we did the same sort of thing.
Sorry, James, isn't that always the way, though? If you're going to understand the technology, you've really got to understand the people involved in the technology as well.
Yeah, and what value is it going to add? Because sometimes you just don't know if it's really worth your while. But we used the same logic with Scintam, in that we saw an SME that had an interesting piece of technology that we believed was being used in a kind of handheld drill fashion, which was great for plenty of applications, I'm sure, and ones that we maybe don't know about yet. But we thought if we could remotely deploy it on a kind of small tracked vehicle with a robot arm, then we could get the same sort of value add in terms of dismantling a bigger bit of architecture or infrastructure, with remote means.
So this starts to sound a bit kind of science fiction. We're going to have a robotic platform, and then we're going to deliver some kind of spark erosion tool.
Yeah, give a robot a gun.
Give the robot its own EDM gun, and set it off on an adventure. What could possibly go wrong? But that must have created significant technical challenges. I mean, that this is a first as we understand it, and a first, I guess, as you understand it.
Yeah.
Surely it's not as straightforward as that. You just get one thing and bolt it to the other. It's got to be more complicated than that, hasn't
it? Yes, certainly. And there was challenges on both sides, I would argue. One of the more sort of challenging things that we hadn't necessarily considered until we properly started bolting things together was actually the cable, and managing the weight or the mass, the stiffness of the cable that goes between your control box and the EDM gun. And that was something that we were trying to cope with, I suppose, as we were moving a robot arm around to kind of position your gun to the right place. So the biggest challenge we faced, I think, was around.
So just to remind me, you've got basically a robotic cart. There's an arm on top of that, and they can be automated. They're controlled by an operator ex situ.
Yeah. So there's a few elements of it that brought in some autonomy, and a few elements of it that were remotely controlled. Mm-hmm. So the bit that gets you from A to B looks like a mini tank that's got caterpillar tracks. Then on top of that, you've got your control box, almost like a little trailer hanging off the back of it in a way. And then and next to that, we've got a 6 degree of freedom off-the-shelf robotic manipulator. It's called a UR10. But generally speaking, that is the thing that's moving our sort of tool center point, if you like, which is essentially your EDM gun in this case. But we also added a vision system to the top of that, mm-hmm. which allowed us to automatically find and locate bolt heads. Mm-hmm. So this was the bit that we spent the most time, I think, really on from a robotics perspective, because we didn't want to have to control that part manually. We can drive the tracked crawler in a kind of gross positioning way, but then we use this semi-autonomous way of manipulating and moving the head to the right place to get the bolt head captured. And then also, going back to the human factors bit, this is one of the first examples where we had some robotics engineers looking at it and making an interface. And what they thought an interface was very different to what a human factors person might look at and say, actually, that looks like an interface that a person that doesn't know what's going on could understand, and not looking at lines of code and script. I'm thinking that's kind of something that would be a difficult thing for a lay person like me as a humble metal basher mm-hmm. to look at and think that's what we could operate a robotic system with.
So the vision for a technology like this would be, I guess, that everything's automated, that you would give the robotics system some broad parameters about the space and the task, and it would go off on its merry way, find all of the fasteners that needed to be removed, and you would come back in 6 months, and there'd be a nice neat pile of components that it had disassembled.
Yeah, I'm not sure about 6 months, but it's definitely, that's the general concept that we're trying to look at developing here. And what we have done adjacent to this project is develop a way of going into a cell, for example, a decommissioning area that you might not have looked at for several decades, perhaps, but to do a full scan in terms of a 3D geometry map, but then also look for chemical leaks as well as radiological hazards and things like this, basically taking the lab to the target. And then that type of thing would then go out, pick up a new tool to start thinking about when they kind of figure out what parts we need to take apart. And it's at that point where we think, well, actually, you might need an EDM gunner to remove some bolts from different sub-assemblies, for example, to get access to places. You might want to go back in with a laser cutter, for example, to lance off a few pipes that we think are benign. But it's part of the tool set, we think, of a potential remote decommissioning system. And I'm saying decommissioning, it might not be, but we think there's probably application, certainly in the nuclear decommissioning field. Probably also in places like shipyards, where you've got big areas where you don't really want to put people.
So it's like it's dismantling utility knife almost. You've got a many for one, lots of tools on a single platform. Brilliant. So back to the people side of things, James. When we've worked in the past, you've been a little bit of an orchestrator, almost bringing people problems and solutions together. Could you say a little bit about how the team came together and how people stepped up to help the project move forward?
Yeah, really pleased about how all that sort of took place, really, because yes, I was sort of responsible for joining a few people together initially, but really the main bulk of the work's been done by a really talented group of people within both Manchester and Amentum. So really pleased about how the team came together within Cradle. And on the University of Manchester side, Sky and Danish were instrumental in kind of putting things together from a robot perspective over there in Manchester. In our side, Marty, Amber and Michael Oates were probably the most influential people within the group, kind of putting certainly a lot of instrumentation and all that automation around the vision system together, and really responsible for making it happen from an integrated perspective. Because, when you talked about it's not just bolting stuff together, lots of it was actually. And we were kind of trying to do things quite quickly and in, let's say, a cost-effective way. Because now we're looking to try and get funding to make that concept look a lot more like an engineering product that people could use.
Fantastic. And then at some point you connect with Peter Smith and Sam Catchpole Smith at Scintam, and you show them the opportunity, the problem, and how did that work out?
All the guys in Scintam were fantastic. We were always kind of challenging them with various different technical aspects, but it was always really interesting to see how they kind of stepped up. And I know that there was always a time pressure on them because they were delivering things to customers, and quite rightly, those things took priority. But they were really interested in engaging with it. They said they've had the same sorts of ideas, but through their general work, they haven't had time to kind of pursue these types of ideas. So I think it was a really nice sort of Venn diagram, I suppose, of us having some time and inclination and those guys having some ideas to bring to bear as well.
So it's a really good point that you make, James. When you're a relatively new SME, you've got to be customer orientated to deliver in the here and now. And then the big picture stuff, the strategic opportunities, don't always come to the fore for two reasons: time and largely paying for them. So being able to piggyback on projects like this is really useful, not just from the perspective of developing, let's say, a non-mission critical technology at this point in time, but also building a network of end users that we can link up to when the time is right. So
Yes.
go ahead.
Sorry, can I just dive in? One thing we haven't spoken about is we pushed on towards a demonstration, and we invited a bunch of potential end users that we know of in the industry through our links, and all of the team really pulled together to kind of make that happen. And it was a really smooth event in the end. It was one of the kind of best sort of demonstration things that I've been involved in. It went off without a hitch, and there was loads of stuff going on in the background to make it happen in an unseen way. But it was one of those kind of swan on the water moments where lots of stuff was going on underneath the surface, but it all looks great on top.
So I don't think it would be British engineering unless the demonstrator had some kind of panic moments halfway through.
Oh yeah.
But the report that I got of the demonstration, I think swan-like was a term that I heard as well.
Was it? That's interesting. Yeah, the team did a great thing.
Let's just think a little bit about the next stages for something like that. So there's a demonstrator available. You have a group of potential clients who are interested. Where does this go next? What does the future hold for this technology?
Yeah, so we're a consultancy, so we're not flushed with lots of spare cash to develop technologies that we think are interesting. What we're classically doing is developing things specifically for customers' needs, clients' needs. But we are very interested in trying to find funding opportunities to move on concepts that we think have value, and we think this is one of those. And all the ingredients are there for a really good consortium-led research project funded by some part of the UK government, something like UKRI, for example. So you've got an SME like Scintam with a really interesting piece of technology. We could be an integrator and sort of potentially help commercialize and deploy a service. We need some end users on board, which we think we've got. It's just a case of finding the right funding opportunity and putting a proposal out. So that's where we are just now.
Mm-hmm. And with respect to the end users, the immediate connections largely relate to energy generation or energy storage. Do you see other applications for the platform that you've developed?
We talked about shipyards being potentially one. I think there must be, absolutely, and I think it's a case of always people needing to see it and then thinking, right, I make that connection with I could make use of that in my operation. I'll kind of get on the phone to one of those two people. But one really potentially interesting one we've picked up is taking apart the International Space Station, because that's got lots of fasteners on it that have been high torque, I suppose, but then very interesting kind of atmospheric conditions in that they're also in a vacuum and potentially seized up. They might also be welded up. So it might just be that Spark EDM isn't right. But it's an interesting thought experiment to start with at the moment.
Well, without being too precocious, let's hope that some of them are seized.
It'd be great.
While being safe and meeting their engineering requirements, but from Scintam's perspective, let's hope that there's some seized fasteners that we can.
But it's a thing that's reaching at the end of its life, and it's going to need to be dismantled. Otherwise, it's going to be a big, dangerous lump of stuff.
It's interesting for us, James, working in this space, because a lot of our current customers are looking to adapt service processes, so particularly in aerospace, where Scintam's developed a bit of specialism. We have strong connections into some of the MRO companies now, looking at assisting them with their repair routines on engines that have been in service. So these are not legacy engineering systems like some of the things that we've talked about already. These are very much being used in anger. And it's all about refining the service protocols to get things back into service. So we're just delighted to work with companies like yours, which gives us another arrow in the flight, if you like, or another string to the bow. Go ahead.
I might just add something to that, because I think we've since carried on the conversations with Peter, and I think we're in the process of maybe offering some consultancy work to help that that aerospace application with your existing customers, maybe providing some sort of smart tooling, I suppose, that helps your system do its job. But yeah, more to follow on that one. I'm quite excited to see where it goes.
Fantastic. I was at Aeromat a couple of weeks ago, which was in Vancouver, actually. And at Aeromat, there was more than a handful of aerospace fastener companies who all made similar claims about their fasteners being the best in the business, of course. Their fasteners never seizing, never having any problems. And I toured all of those stands. And when I chatted to the right person, they would say, on occasion, it might be useful to have a technology to remove some of those fasteners. So we hope that there's a bright future for Scintam in all of this, and also a bright future for robotic automation of innovative spark erosion in whatever form it may take in the future. James, conscious that you are a very busy person currently traveling on a conference, I think we should probably thank you for your time and hope to see you again soon.
Thanks very much. Pleasure to be on your show.